Hello friends, for today's project I'm going to be making a solar-powered sand battery for off-grid heating. But what's a sand battery? Well, a battery of any kind is a way to store energy. Usually when we're talking about batteries, we're talking about the electrochemical kind, the kind that power our cell phones, flashlights, cars, things like that. But energy comes in many forms, and there's lots of ways to store that energy. If we want to reduce our reliance on fossil fuels, finding ways to store renewable energy is super important. In this case, we're going to be converting solar energy into heat energy and using sand as a thermal mass to store and re-radiate that heat. We're going to be building a small sand battery that I may use to heat my duck enclosure or maybe to heat a greenhouse, but you can scale this idea up to heat larger spaces, including a home. In fact, Finland has built the world's largest sand battery. It's about 50 feet in diameter and 40 feet tall, much bigger than our little Goblin project here. In an article in the Helsinki Times, it says this new installation reaches temperatures between 400 and 500 degrees Celsius. Well-insulated storage ensures that heat losses remain around 10%, enabling the battery to provide warmth during Finland's winter months. According to Polar Night Energy, the battery can store enough energy to heat approximately 260 homes for a week. The system is expected to reduce heating-related emissions in Pornainen by nearly 70%. That equates to an annual cut of about 160 tons of carbon dioxide emissions, and this aligns with Finland's goal of achieving climate neutrality by 2035. But using thermal mass to store heat and regulate temperature is nothing new. Since ancient times, humans have used hot rocks from campfires in various ways to provide heat. Pre-industrial homes in places that get hot during the day and cold during the nights were built of earth and materials to absorb the heat during the day and to keep the home cooler, and then to re-radiate that heat at night as warmth. There are examples of this in Egypt, the American Southwest, and more. Anyway, let's get down to making our sand battery. For this project, you're going to want something to put the sand in. You could use a terracotta pot. In this case, I'm using an old cook pot. This may not be big enough, but we're going to learn as we go here. You're also going to need a solar panel. I had this old portable one laying around. We're going to use this one. We're going to need to know the open circuit voltage, which is 24.4 volts. You can get that off of the product specifications for any solar panel you're using. Usually it's on a sticker on the back. We are also going to need a heating element. I'm using a water heater element from an RV. Some people use stovetop electric stove elements. Those work as well. We're going to compare those two later on. You'll need something to connect the solar panel to the heating element. I'm using these cables I hacked together out of some spare parts that have the same MC4 connectors that are on the back of the solar panel here, so that it's easy to connect. And then you'll also need a thermometer, that's kind of optional, and a multimeter if you want to keep some good notes on what you're doing for future improvements. And this is just a cheap big box multimeter. You don't need anything fancy for a project like this. Since we need to know the impedance or the resistance of this heating element for future modifications or improvements that we might make to this, we're going to use our multimeter to measure that. So for this, we're going to turn it to checking for resistance, and we're going to check it on the lowest setting possible so we can get the best accuracy. That's all we need for this. And then we're going to just connect the black and the red. We're going to touch that to each of these terminals here, and that's going to give us our impedance. 15.2 ohms of resistance is what we'll use. 15.2. So how much heat will this thing put out? We don't know yet, but we can get some important information that will help us to improve the setup at a later date if we need to. We'll have to do some simple math to get this information, and if you're new to solar, this will be good info for you. The voltage of the solar panel will change with the intensity of the sun, but we'll use the open circuit voltage, or VOC, from this panel that we noted earlier. Remember, that was 24.4 volts. And we'll need the resistance of the heating element. We used the multimeter to test that and found it was 15.2 ohms. In order to know how many watts of power this thing will produce, which will be stored in the sand as heat, we'll need to multiply the voltage from the solar panel by the current draw. The formula for that is power equals current times voltage, or P equals I times V. And don't ask me why current is represented by an I forgot. We already know that the best case scenario of our voltage from the panel is going to be 24.4 volts. But what is the current? To determine that, we're going to have to work backwards a little bit. Since we know the voltage of our solar panel, 24.4 volts, and the resistance of the heating element, 15.2 ohms, we can use the formula for Ohm's law to determine the current. And the formula for Ohm's law is voltage equals current times the resistance, or V equals I times R. We'll divide the voltage by the resistance to get the current, and that is 24.4 divided by 15.2 equals 1.6. So the electrical current in this circuit will only be 1.6 amps. And now that we have our current, let's back up to our first equation, and then we can solve for P, since we now know I, which is the current, and V, which is the voltage. We'll multiply 24.4 volts by 1.6 amps, and we get 39 watts. So our little sand battery will be storing 39 watts of power. And that's not much, but we'll see what the practical results are after a day in the sun. If we want to increase the power output of this thing, we'll have to increase the current or the voltage. That means a bigger solar panel or more current or both. I found information online stating that the average 8-inch stovetop element is around 27 ohms of resistance, give or take. So if we use the same formula for Ohm's law, voltage equals current times resistance, we get 24.4 volts from our solar panel divided by 27 ohms of resistance for the stovetop element. That gives us a current of 0.9 amps. Now, multiplying that current by our solar panel voltage, 24.4 volts, we get 22 watts, which is less than our 39 from the heating element. So this is why we're using the water heater element instead of a stovetop element for this project. All right, enough of that. Let's slap this thing together and see what happens. All right, so now what we have to do is we have to connect the solar panel to the heating element. I've got the pigtails connected to the heating element here. It doesn't really matter for our use case here which side goes with which, positive or negative, doesn't really matter. So we're just gonna put some sand in the bucket, bury the heating element, connect it up, and let it run and see how hot it gets. That's basically it. All right, so here I've got it all hooked up. Got the solar panel connected to the pigtails, connected to the heating element, stuck in the sand. And now we wait and see how this heats up here. I may want to make sure that those cables aren't touching the metal, depending on how hot the metal heats up here. But this is where the temperatures sit right now for the sand. So we'll give this a few hours and keep an eye on it and see what we end up with. Well, it's been 24 hours, so how did we do? Terrible. But that's not a bad thing. We learn by doing, so what did we learn from this? Well, let's start with the objective observations. With this particular setup, the temperature of the sand only got up to about 125 degrees, and as soon as a tree cast shade on that solar panel, the temperature quickly started dropping. In the evening, I put the sand battery into the duck enclosure I was hoping to heat, and I kept track of the temperatures. Now don't worry, the ducks are kept warm in a different enclosure at the moment. That means nobody needed to be reliant on the success of this experiment, and that's important. More on that later. By the time I put the sand battery into the enclosure, it had already cooled to the ambient air temperature for the evening, which was about 80 degrees. By 6 a.m., the temperature had dropped to 60 degrees, and the temperature in the enclosure tracked exactly with the air temperature. In other words, the sand battery had zero impact. If I had to rely on this particular iteration to provide heat for animals or my family in an emergency situation, it would be a complete failure. And that brings me to an important point I want to make. YouTube is full of off-grid and emergency prepper hacks, and most of these don't work. If you see 20 examples of how to do the same thing on YouTube, it's real easy to get the impression that a given hack works. But until you try it in a low-stakes context, you don't know, and I think that trying is super important. As a specific example, when I was planning to spend time doing van life as a stepping stone to off-grid living, my social media feeds were absolutely swamped with people making these crummy little tea light and terracotta pot heaters. Maybe you've seen some of those on your YouTube feed. All of these videos came with the clickbaity promise of safe, effective, off-grid emergency heat. And this particular type of heater is one of many heating ideas I tried before starting van life, while I was still living in an apartment and could turn the heat on and test this in a safe, low-stakes, controlled environment. No matter how many times I iterated on that tea light heater idea, it failed. And if I never tried it before for myself, I would have never known. And if I had actually needed that for heat, the results could have been tragic. And this is the value in doing projects like this. You learn by doing. But back to the sand battery and the reason I was taking notes and measurements. I think this idea could be iterated upon and ultimately have some use for winter greenhouse heating. Here's my thinking. In this case, size matters. We know that with the solar panel I was using, we were only getting 39 watts at peak sunlight. That's not much. And where the duck enclosure is located, it doesn't get much sun at all. So even with a bigger solar panel, that use case wouldn't work for me, not in this situation. Additionally, we only had an 8-quart stock pot filled with sand. That's not a whole lot of thermal mass. On top of that, the metal cookpot conducts heat to the outside air very well. It's not insulated at all. So I'm thinking this may still work for a greenhouse. I don't have the greenhouse built yet, but when I do, it will be necessary to build it in the sun. I'll be able to consider larger solar panels for a permanent install on the roof of the greenhouse. And I'll be able to build a larger, more insulated sand battery, perhaps using a 55-gallon drum and concrete blocks. I've got some ideas. But the point is that I'll learn by doing and build and test that idea before it's needed. That way, if it doesn't work, then I've learned something and not suffered any loss. And I'll still have time to figure it out. But what about you? How would you have improved on this? Drop a comment and let me know, and have an awesome day.